Okay, can you hear me? Okay, good. So first, hi and welcome to this talk. And that's a pretty presumptuous title, isn't it? So please, everyone, come and see how I work with JSON. Right? I'm very self-conscious. My name is Einar Høst. I'm an old software developer. I've been sort of programming for money for 20 years. I work for the Norwegian Labor and Welfare Administration. And today I'd like to talk about three things that sort of pertain to working with JSON. First and foremost, and the most important thing, and the thing that I'm going to use most of my time on, is how can we sort of work with JSON in a simple way, so simplicity. Then I'm going to talk a little bit about contracts. So in particular, contracts as a means to be explicit, which is something that then again can help us to achieve this goal of simplicity. And finally, I'm going to talk a little bit about testing. It's an important disclaimer for me that there are going to be no advanced techniques at all in this talk. And I hope I made that clear in the abstract for the talk, because that's sort of the contract between me as a speaker and you as an audience. I think I did, but well, we'll see about that. In fact, it's sort of going to be a talk about the opposite of advanced techniques. I'm going to argue that to the extent possible, we should try to refrain from using advanced techniques when we're working with JSON. And the reason for that is that we're trying to aim for simplicity, which are sort of at odds with each other. So JSON. In preparation for this talk, this was the first slide I made. And the reason for that is that somehow we managed to turn working with JSON into this sort of complicated mess. And I think we did so in an effort to make it easy, which is kind of a sad result. So there is an element of feeling like I'm too old for working in this manner. Too old to sort of be chasing down weird behavior in code that handles JSON. But even more importantly is that you're too young for this, right? You should not be spending time working on weird behavior in JSON serializers, right? You should be doing something more interesting than that. Now, I need to add one caveat. So this talk is about how we, from my experience, how we typically work with JSON in .NET, right? So working inside a statically typed programming language. If you work with a dynamically typed programming language, like JavaScript or Clojure or something like that, some of the problems that I'm going to talk about might seem sort of weird or quaint to you. And that if that is the case, I sort of suggest that you sit back and sort of enjoy your feeling of superiority and smugness for a while. Savor it like it's a piece of fine chocolate, and let's all hope that you don't choke on it. So the reason for this entire thing, let's start with this question. Is JSON a complicated thing? Right? So if I create a scale from simple to complicated, where should we put JSON here? Is it over here towards the simple end? Is it somewhere in the middle? Or is it actually quite complicated? To answer that, let's go to JSON.org. I think that's what it's called. And look at what JSON really is, right? So JSON value can be one of these things. It might have some white space and stuff. Then it might be either a string, or it could be a number. It could be an object. It could be an array. And then it could be one of three sort of constant values, true, false, or null. And that's sort of all there is to it. But of course, there are some details here. So a white space might be one of these things. It could be a space, or line feed, characters returned, horizontal tab. A string, a little bit more complicated perhaps, starts with a quote. And then it could have basically anything except a backslash or another quote. And if you have a backslash, then there are some rules for what characters are allowed in that case, and so on and so forth. And this allows you to escape characters in JSON strings. But still, it fits on a slide. Then we have numbers, and JSON numbers can be integers or decimal numbers, and it also supports scientific notation. Objects have these sort of like curly bracket things, And it could be empty, so it's just sort of degenerate object, or it can have some properties. And properties have a JSON string for a key, and then it has a colon, and then it has another one of these JSON values. So it's recursive in that sense, right? Arrays, even simpler. Bracket could be an empty array, or it could have a comma-separated list of values. And that is JSON. And from this, I'm going to make the bold claim that JSON is not complicated. It's actually very, very simple. It's hard to imagine, in fact, to have a format that you can go very much farther in the direction of simple, right? You would put something like YAML in an entirely different place on this scale. Right? The YAML specification for YAML 1.1 in the PDF format is 86 pages. That is more complicated than JSON. JSON is simple. What about the code for handling JSON? The code that we typically write to handle JSON. Let's invent another scale from trivial to non-trivial. And I'm talking now about the sort of the mental effort you need to work out exactly how it works. Would you put it here? No. Or would you put it somewhere toward the non-trivial end? And if you do that, why would you put it over there when JSON is simple? Is it because performance reasons? Because performance is sort of a valid concern always, right? So if you have like gigabytes of JSON documents coming at you 100 times a second, maybe you need to do something to make sure that that's a fast process. And maybe you should be looking at some other formats than JSON also, but that's a sort of another problem. If you do make your JSON handling code more towards the non-trivial end to achieve performance, I would highly recommend measuring and making sure that you actually get the performance benefits that you think you're doing. If, on the other hand, the purpose for making the code or the whole process of handling JSON non-trivial is to eliminate some boilerplate code, then we're going to have a conversation. Now, first, when you eliminate boilerplate code, you don't really get rid of the boilerplate code. You just move it somewhere else, right? So you get rid of the body, but the spirit still lives somewhere, right? And it lives specifically inside some library, some magic box that does some metaprogramming to do the same job that your boilerplate code is doing. So let's talk a little bit more about boilerplate. Is boilerplate complicated? On a scale from trivial to non-trivial, where should we put boilerplate? Well, at least boilerplate for handling JSON is so far towards the trivial side. It's so brain dead and so repetitive that it's sort of an insult to our fine minds to be typing it out. That's how trivial boilerplate is. Now, there are some benefits to trivial code, right? Let's talk about the benefits of trivial code. First of all, it's trivial. That's basically the main advantage. But trivial code, then, is easy to read, is easy to test, is easy to change, and it's fairly trivial to spot and fix mistakes. It doesn't get much easier than fixing mistakes in boilerplate code. That means that anyone can work on it. You don't need any special knowledge. You don't need a lot of experience to do that. There are no hidden workings, no special dependencies that can come out and bite you. And that means that there's little fear also when you change something of introducing some weird bug. And if you do introduce a bug, it's fairly obvious what the cause of that bug was. Okay, so there's a famous talk by Rich Hickey. Rich Hickey is the inventor of the Clojure programming language. It's called Simple Made Easy. And in that talk, well, he distinguishes then between simple and easy, right? That's fairly obvious from the title. And he talks about what it means to be simple, what it means to be easy, how we tend to confuse those two things, and why that's a problem. And according to Hickey, apparently he was looking at sort of the history of the word simple, and it means not intertwined with something else, right? Not mixed up with something else, just one thing. And we find sort of the same thing in different kinds of advice and principles in software engineering, like the single responsibility principle that says there should be one reason to change, and you tend to get that when things are not mixed together, right? There's also the old sort of design advice for Unix tools that says that tools should do one thing well. Sort of the same idea. Now, the opposite of simple is complicated. And complicated, that means that things are intertwined, right? Not just one thing, you're doing several things at once. Easy, on the other hand, means something entirely different. Easy means that it's convenient, it's close at hand. And it can feel very convenient to do multiple things at once, right? We have sayings like to kill two birds with one stone. Very nice. Now, unfortunately, I think we like to say that we like simple code, right? We say simple, but unfortunately, we often mean easy. We say that we like simple code, but we tend to choose convenient code. And that means also that we tend to choose magic over transparency and making things explicit. Now, what does all this have to do with JSON? Well, one thing is that the authors of JSON serializer libraries, they know all of this stuff. They know that we appreciate convenience. And therefore, many JSON serializers optimize for convenience. Many JSON serializers are way too ambitious. They want to help us too much. That's a strange thing to say, but it's actually a problem that they're trying to do too much for us. Of course, at this point, you may be thinking, what the hell is this guy talking about? But to answer that, let's sort of drill into exactly what this process of JSON serialization really is. What's sort of the essence of it, right? Well, I made a drawing. It's something like this, right? It's actually a two-way process. So either you have some sort of data structure in memory, and you want to convert that into a string representation in the JSON format. That is the JSON serialization. When we talk about JSON serialization, we also tend to include deserialization, which is going in the opposite direction. That means that you have some JSON formatted string thing, and you want to sort of tokenize and parse that and turn it into one of these data structures in memory. Of these two processes, deserialization tends to be the hardest one. Yes. Now, is this difficult to do? Is it simple, since we'll be talking about simplicity? Well, the answer is it depends. It's not necessarily super simple, because anytime you're parsing something, it's not necessarily super simple, but it doesn't have to be super complicated either. So I'm even going to say that it's going to depend a lot. It's going to depend a lot, in particular, on that data structure, right? We didn't specify what that data structure was, and how that now relates to the JSON text you have. So let's take a look at this figure again and see if we can make it more explicit. We can sort of split it up a little bit further into something like this, right? So you have your data structure on the one hand, then you have some sort of mapping towards sort of like a conceptual JSON object model, right? It doesn't necessarily have to exist in your program, but conceptually, you're going to sort of map it over to the JSON object model, and then you serialize that, which is sort of like a mechanical process. And then it goes the other way around as well. Now, it gets even worse than this in a sense, because now I'm doing this, I'm assuming that I'm just having one data structure. But in a practical situation, it might be that you have one producer of JSON, and you have another that's the consumer. So you now do map over to the conceptual model, and then you map to some other data structure. But to sort of simplify the diagram, to simplify the discussion a little bit, I'm going to pretend that we're always going to deal with this same data structure. Now we have on, I guess, the right-hand side, the process of serialization, a pure serialization, if you will, on the right. So let's look a little bit about that in detail. So you have the pure serialization. This problem has some very nice properties. First of all, it's a well-defined problem. We know exactly what goes into this. It means it sort of captures the essential complexity of serializing and deserializing from text, from text in the JSON format. And that means it also has a bounded complexity, right? There are no outside sources of additional complexity to solving this problem. The only thing that can really add any complexity here is if the JSON format itself changes in some way. And that happens rarely. It has a minimum of failure modes. So basically, okay, probably some computers can always fail, right? But apart from that, what can happen? Not a whole lot, right? If the text happens not to be JSON, then it's going to fail. That's okay. But as long as it's actually valid JSON, you're going to be able to deserialize it into an object model for the JSON data format. Now, it's sort of an interesting engineering challenge to turn this process into something that uses little memory and it's blazingly fast. And this is sort of a problem that you want all the clever programmers in the world to sort of compete to achieve in the best possible way, right? And then you can use their final results to do that. Okay. Let's look at what sort of remains now. The mapping from the data structure to the JSON object model. What sort of characterizes this problem? What kind of problem is this? This is sort of like a general, arbitrary data mapping situation from one data structure to another. And unless you know something about that data structure that you're sort of trying to map to and from, you don't know how hard this problem is. So it has some unfortunate properties. It's very different from the pure serialization problem. So it's ill-defined, first of all. There are a lot of open questions here because we don't know what that data structure is. You don't know if there's going to be some sort of impedance mismatch that's going to make this process hard. Maybe there's going to be some information loss going in one or the other direction. Maybe there is some data transformation going on. And all of these, the answers to all these questions may introduce new failure modes, new reasons for this to fail. And in a sense, this problem has unbounded complexity. You can make this arbitrarily hard by sort of moving the data structure far away from what the JSON object model talks about. Now, in a situation like this, I'm going to argue that you want direct control over what happens. Right? You want maximum transparency. You want to know, to be able to inspect exactly what's going on in this mapping process. That means you need explicit code. But let's say you don't do that. Let's say you opt out of having explicit code because that's boilerplate and it's boring, and you decide to use some library to do that mapping magically for you. What happens then? Well, that mapping process is going to have to rely on heuristics and guesses. That's how it can do its magic, right? It's going to assume some things about this process. It's going to rely on names and conventions and stuff like that. And of course, because heuristics can be wrong, it might offer sort of a broad set of them, and you can choose between them. So you have some configurations options. And then you might be able to provide like hints and stuff and guidance to in addition to these heuristics, for the cases when it doesn't really produce what you want. So you can annotate your target data structure, if you like, to help the library achieve what it was supposed to achieve automatically, right? Of course, this now couples you and your data structure to whatever library you're using. And finally, if all else fails, you may be able to write some plugins for your serializer library that sort of fits into this larger magic machinery that you're relying on. And of course, to write one of these plugins, that requires quite a lot of in-depth knowledge about the library you're using, right? And I've tried to write some of these plugins, and it's not trivial. Whatever it is, it's not trivial code, right? It usually has mistakes in it, because I'm not an expert on that magic machinery. But all of these are sort of mechanisms now to regain some of the control that we lost when we said that this is going to be handled magically for us. And it's always going to feel a little bit like this, right? Trying to control, you're going to have some buttons and some levers, try to pick up that thing and sort of achieve your goal that way, but it's always going to be a black box and much more cumbersome than just sort of reaching your hand and grabbing what you want. Let's talk. I'd like to say a few more words about sort of writing these plugins, because I've gone down this road, right? Now, one of the problems is that when you're writing a plugin to a parser, you're writing a parser. And writing a parser can be a lot of fun. I think writing a parser is fun. especially when it doesn't have to work that well. Writing a parser can be educational. You can learn a lot from it. It's a nice kata to do. If you do it on your free time, that's cool. But whatever it is, it's not simple. Writing a parser is never simple. Even for something as simple as JSON, it's not trivial to get it correct, and it's not simple code. Right? Parser code is not going to be trivial. And finally, writing a parser is probably not in your core domain. Right? This is probably not why you're hired as a programmer, to be writing a parser. And it might be that you should invest your time and your effort and your brilliant mind on something more important. Okay, so let's return to this ill-defined problem. What should we do in this situation? And one thing is that you can eliminate this process altogether and just work with the JSON object model. That's one choice. And it's not as bad as you might think, but of course, that means that there might be sort of this. You need an explicit representation of the JSON object model somewhere in your code, either from the library you're using, or you're going to have to write that yourself. And you might not think that's a very good idea. So what you can do instead, and that I recommend doing, is to use a minimal mapping. You could avoid, you can avoid a lot of problems if you try to. You can have this mapping, but you make it as trivial as possible. And one way to do that is to use something that I like to call a JSON DTO. So DTO is a data transfer object. JSON DTO is one that's sort of specifically tailored to represent JSON data. That means there's going to be no transformation of data here, no configuration, except it might be, if you have an overambitious JSON serializer, you might have to turn some things off. That might be your configuration. I'm going to come back to that later. No annotations on these JSON DTOs, because they won't be needed. And you're definitely not going to write any plugins. And this, I think, is a process that is OK to automate, right? Because you answered a lot of those open questions in the simplest possible way. So for this process now, we're going to leave this right-hand side to the JSON serializer. And it's going to solve a well-defined problem. And that means that you can take whatever JSON serializer you have, and if a brand new, super fast, zero allocation JSON serializer comes along, it's going to be very trivial to swap it, right? Because it's going to solve exact the same problem, right? So now the JSON standard is going to be the contract that these JSON serializers act upon, not whatever list of features they happen to support. And then this is going to be handwritten. And yes, I know that this is going to sound, oh man, I'm going to have to write all this sort of trivial mapping code. That's exactly the point, right? One of the nice things about handwriting this also is that if there are tiny, minute variations inside of this boilerplate code, it's trivial to do that. Whereas instructing your a sort of a magic box to do that is much, much harder. Okay. And now you're also free to let these sort of data structures you have be actual genuine domain objects without concern of how hard it is for the JSON serializer to actually be able to serialize into your domain objects, right? You don't have to sort of fight, have this battle, so, oh, am I going to encapsulate this? But then it's going to be harder for the JSON serializer, but proper domain objects should be encapsulated and so on and so forth. You're going to sort of sidestep all of that and just take manual control. Okay, so what exactly are these JSON DTOs that I talk about? So DTO, data transfer object, but it's going to be some additional constraints to make working with JSON extra simple. Now, they're going to be just property bags, sort of typed property bags. Now, JSON objects themselves are sort of the untyped property bags, right? So like dictionaries almost. JSON DTOs are typed property bags. They have a default constructor, makes it very easy to sort of create for the serializer. It has getters and setters, and then it can, and this is sort of the crucial part that makes it specific for JSON, is you can only use types that have some sort of direct counterpart in JSON. Now, what I mean by that? Well, I mean that we can use strings, .NET strings, mapped to JSON strings, right? You can use integers and doubles because they map naturally to numbers in JSON. You can use, whenever you have a JSON object, you can use another one of these JSON DTOs. And then for arrays, you can use arrays. That's the only collection type you're going to use in a DTO. No lists, no I read-only list, no collection, none of that stuff, just an array, right? You're going to know in advance how long that thing is. You're never going to append to it, stuff like that. And finally, you have a bool that's going to cover true and false. And of course, null is the absence of one of these objects or arrays, I guess. Did you notice that there was no date time here? Right? There are no date times in JSON DTOs. And the reason for that is that JSON has no concept of time. We didn't see any date times in the sort of the specification for JSON. The JSON is all just a string. It happens to have some sort of format. That's a detail that JSON doesn't care about. And you might be sitting there thinking, surely we should be making an exception for time. Times are so important. We have a lot of timestamps. It is so boring to do all this mapping by hand. Surely. No. And actually, I'm going to double down and say, hell no. Because this is the siren call of convenience. This is easy. We want to use it because it's there, right? Newtonsoft does this for us. It's so easy to use it. But easy is not the same as simple. And we know this from experience that we get time wrong all the time. In fact, I'd like to show you an example. See if I can make this work. I have some code here. Can you read this okay? So this is some code. It uses the Newtonsoft. Newtonsoft is sort of the most popular JSON serializer library in .NET. It has probably more downloads than sort of atoms in the known universe. Everyone uses Newtonsoft. I'm going to try here. So the point here is that I'm going to try to, well, I have this JSON text that represents an object. And that object has one property called a timestamp. And it contains a timestamp, right? A formatted timestamp inside a string. And I'm going to deserialize that into a J object, which is sort of like Newtonsoft's representation for the JSON object model. And then afterwards, I'm going to pick out the timestamp, and I'm going to write both things to the console. Very easy, right? Let's see. I'm going to try to run this code now. See where we are. Yeah, I have my datetime console thing, .NET. How do you do this thing? .NET developers, please help me. Something like this, right? I'm going to execute this code. Hopefully it works. And now you can see what was outputted. What happened to my string? I had a string here. It says very clearly what the string is. And then I picked out the string and I got this. Now I can turn this off. This behavior, this is Newtonsoft trying to help me, right? Because it tries to parse it, sees that it's, oh, it actually is a datetime thing. And then it does something to it. I don't know where sort of my offset information got to and why it sort of reformatted everything. And I don't care. I don't want to have to figure it out. So yeah, we get time wrong all the time. Let's see. I'm going to try to return to my presentation now. And sort of the lesson here is that whenever you're surprised by some behavior, you should make it explicit. Whenever you're surprised by some behavior, we should get rid of all the magic. We should choose control. We need to know exactly what's going on. So there's nothing to figure out, because it's right there. Now, okay, so speaking of surprises, you know that bugs are the name we use for surprises, right? But where else can we find bugs? Except then in non-trivial code that changes or in code that deals with time. we tend to find, from my experience at least, we tend to find bugs in between systems, right? And system boundaries also often correspond to team boundaries, which means that usually there are some people that are going to have to communicate for things to work well. And of course, we know communication never goes well. There are always misunderstandings, right? It's inevitable. So we find bugs in the integration at the borders of our systems. And what's sort of the lingua franca that we tend to use at borders? Well, it's our friend JSON again, isn't it? Of course, often, not always, I guess, but often we want it not just to be JSON. It's not enough that it's sort of application/JSON. Usually we want it to be the right JSON. We have some assumptions about the data being passed from one system to another, right? So you have some sort of communication situation using JSON from system A to system B. And I don't really care in this situation whether that's a web API or if there's some sort of message on a message bus or something like that. It doesn't really matter in this context. System A sends a JSON document to system B because system B needs it. Sometimes there's a problem with this JSON document. And when that happens, from my experience, what tends to happen is that there is a message on Slack. The integration broke. Did you change anything? This is going to be the system B people going to the system A Slack channel and say, this integration broke. Did you change something in your system? And in particular, this question that I've seen so many times, have you changed your JSON serializer config? How is your serializer configured? We have set it up so and so. Perhaps you could use the same configuration so that it's going to match. So there's going to be this sort of frantic looking for whatever it was that changed, right? Either system A changed, or maybe system B changed, or maybe the data changed and we saw some data that we never saw before, or maybe it was just that the unlucky timing in the sense that we hit one of our timing bugs. Right? And I am done with these discussions. I'm never having them ever again, because we don't need to be having these kinds of discussions. The only question that we need to ask is, what does the contract say? Right? We need some sort of contract that answers all these questions or specifies what the JSON's document is going to be looking like. Right? And without a contract, you're going to have sort of an informal contract that's going to be all the documents that ever passed through this integration before and didn't break it. And who knows what that set of documents is? It might not even be a consistent set of documents, because probably in the meantime, both systems have changed. It might not be the same contract anymore. So what do you do in that situation? Well, what typically happens is that you change one or both of the systems to make the integration work again, and then you wait for a while until it breaks again for the same reason, and you have the same Slack message coming. And I am done with this process also. I'm not going to work like this anymore, and I don't think you should either. I have done it for too long. So instead, we need a contract to answer these questions for us, right? And we need to be precise what it means for a JSON document to be valid, right? We need some sort of agreement between system A and system B. System A and system B are going to have some sort of conversation to define what valid means, right? And that might be painful or difficult, but that's sort of where the value add is, right? That we actually manage to describe it. I never want to hear anyone ask about the JSON serializer config ever again. And the reason is that it's an implementation detail. I don't care what you do. I don't care how you do your JSON serialization, right? I would recommend that you use a simple, transparent process with as little magic as you can, but I don't really care. All I really care about is whether or not you uphold the contract. So whenever the integration breaks now, you can ask, well, is the document valid according to the contract? If it is, then the problem is with system B. If it's not, then the problem is with system A. So JSON schema is the format that I like to use to create contracts. If I have a web API, I'm going to use Open API for that, which is sort of, at least in recent versions, it's sort of JSON schema with the additional ability to specify what the endpoints and result codes are going to be, and so on and so forth. For sort of more asynchronous things, message queues and so on and so forth, I like to use async API, which is sort of the same, similar to OpenAPI. And that means that when we have this communication between system A and system B, we don't just send a JSON document over and hope for the best. We have some sort of schema that we can use to validate whether or not that JSON document is actually any good. That allows us to sort of shift the conversation to discussing what the contract says instead of the system internals. And this is what it means to program to an interface. Right? We like to think that we program to interfaces. This is what it means, that you have a contract and then you sort of discuss that. And it's important to note that a contract is not the same as documentation. Often we think that, oh, okay, we just need to document this. We need to document it so that someone else can work with it. But a contract is something more. It's an agreement, right? It's something that we agreed upon that's going to be valid for our communication. And in that context, I'm going to have to talk about, say a few words about reverse engineering contracts. Because this is something that we like to do. We use tools like Swashbuckle or something like that to produce documentation. It's like you have a running server, and then you have some tool that does reverse engineering on that running server to derive a contract. In the case of Swashbuckle, it's going to produce an OpenAPI specification. And I'm really impressed that they can do this at all. So there's some magnificent work done in Swashbuckle to be able to do this. I'm sort of in awe of that accomplishment. And it's also very easy to do, right? You can just turn it on, you download the NuGet package, and boom, you have OpenAPI specification. While I'm mightily impressed that it's possible to generate a valid OpenAPI specification in this way, never do it. Never exploit that power. And there are a couple of reasons for that. First is that a contract really needs to be sort of a first-class versioned artifact. You need to be able to go to contract and see what it says. And you can't have the situation where the API is down, so now you have no contract, and you don't know what it is, because it was derived at runtime. Right? Can't be this ephemeral thing. And what's even more important, that how you happen to behave today is not a contract. That's not how contracts work. So if I rent an apartment from you, and then sort of how much I determine that I should be paying this month is going to be our contract, you're not going to be happy with that, right? You're going to say that's not something that I want to be our contract. That if I want to pay you like $1,000 one month, and then I'll go, well, I don't feel like paying $1,000 next month, so I'm going to pay $500, you're not going to be happy with that. And again, an implementation, this is sort of the same statement, an implementation is not an interface. Well, you should never say things like this, but I don't think in most cases that we would do this at the code level, to sort of automatically have some tool to generate an interface for every class and include all the public members. Of course, someone has probably done this, but that's not what an interface means, right? And for this, you need to write this contract by hand. And yes, this means, again, you're going to have to write something that you might find tedious and that you might have created some approximation to using an automated tool. I'm going to make a bold statement that handwritten contracts are much higher quality than whatever you're able to reverse engineer from your running server. Of course, it's going to be disconnected, so it might go out of sync, and people are terrified of this. But it's going to be much, much higher quality. Of course, you can say that, well, I can always write a plugin to my sort of reverse engineering tool and use that to write sort of arbitrarily good contracts using my plugin. Right? And you can pull in extra additional information using attributes or whatever. And I've gone down this route as well. It's definitely not trivial code. You're going to have bugs. Your contract is probably going to be something else than what the server actually does. So it's probably going to be a mismatch anyway. And anyway, we don't want to be spending our time doing this. And there is no way that you're going to sort of do this work as quickly as I can just type the contract by hand. I'm going to sort of be running at normal speed. You're going to be trying to be running underwater backwards. Right? I can do this much faster. I can iterate much faster on it. And also, you want to use that contract, this first-class versioned artifact, as a collaboration tool with whoever uses your service. Right? You want, ideally, to be co-designing the contract. Right? Sitting with them and typing it out, trying different solutions. You can't do that easily if the way that you're working with it is through some sort of opaque reverse engineering process. Because then you need to actually implement the stuff before you have a contract. This means that you can have shared ownership of this contract, and that makes for better contracts. Okay, so that was contracts. Finally, I'd like to mention a little bit about testing. Now, when you sort of decouple your contract from your implementation, that means that you open up the possibility that there is a mismatch. Right? So you're going to need some sort of test for schema validation. And this, of course, you might find boring to write. There's a tool. There's not a whole lot of choice for schema validators in the .NET space that I was able to find. But there is a tool you can use that's called JSON Schema. It has a nice schema validation support. It also tries to be very convenient. So it has a lot of other stuff, too. Don't use it. OK, just to show you how that might look like, let's see if I can find my validation tests. Right. So this is a very simple test. I have a JSON document, and I have a schema for that document. Let's see if I can find them. Over here, validation test. This is my, let's see. Well, let's actually have it like that. That's fine. Doesn't matter. So I have 2 books here. I have a JSON document with 2 books. And they look fairly similar. That's OK. And I have my, let's see what my schema looks like. This is my JSON schema now. It says that I have, well, an object. This is sort of the root element, or the root value, rather. And it says that it's required to have a books property. That books property is going to be an array. And each item in that array is going to look like this. That's going to have, actually, let's start with this. Right? I'm not going to have any additional properties. You can tweak these things in JSON schemas. You can say, OK, I'm going to expect to have an ID and a title and an author. I'm going to require those to be there. But it's fine to have additional properties. Right? Not in this case, when I turn it off. OK. And so I have also here the ability to say that, OK, my ID is going to be a string, but it's also going to have to satisfy this pattern, which is a regular expression. And the title is going to be a string, but it can only be tops 100 characters. So let's try to run this now. Let's see if it works. So I can do .NET test. How is it going to fare? Well, it didn't go so well. It has a couple of problems. The array item was not valid on the first book. And it says that it's not allowed to have additional properties. And it found this addition property that shouldn't be there. Let's see. Yeah, that's going to be this property here, right? But actually, in order to not be overly restrictive, it might be OK to have these additional properties. So I can just say, OK, I'm going to allow that. Doesn't really matter. As long as I get the data I need today, that's fine. And it might be that in some future version, it's going to be mandatory to have this addition thing. Let's see. And how does that affect things? Right, so now I got rid of that, but it still says that the title is too long, and that's because I sort of mess things up over here, right? This is kind of strange. I can get rid of that. and now everything is fine. Okay, so that's a tool you can use for validating your schema. Finally, I'd like to talk about some tests for expected JSON content. Sometimes, quite often, I guess, it's not enough to verify that that the data is valid according to some schema. Sometimes you want to know that you got exactly the JSON content that you requested. It might be that you're writing tests for your own web API or something like that. So how do you do that comparison? So you sort of have two choices, right? Either you compare them as strings, and that's problematic, but because it's much too low level in a sense, because you're looking just at individual characters. Instead, maybe your comparison can say, well, there's something in this JSON document that has thousands of characters at sort of position 285, there's a discrepancy. And now you sort of, okay, I'm going to have to look up character number 285 and see if I can find out what's wrong. And because that's sort of very low-level information, just captures the first error that you find, right? Because it stops there. Some people turn to sort of comparing objects instead. So they sort of derive this data structure. Maybe they use your JSON DTOs or something like that, deserialize the response, and then you have some expected JSON response, and you deserialize that as well, and then you do the comparison. That's sort of, you can do that, but it's sort of indirect and clumsy, right? Because you're not really comparing the JSON documents, you're comparing something that you derived from them. And of course, if you have sort of this minimal mapping to the JSON DTOs, the distance isn't going to be great, but still. And there's also the thing that by default, .NET objects have reference equality, right? So if you want to compare structure instead of seeing that it's actually the exact same object, you're going to have to implement value equality for your JSON DTOs. That is boring code. That is super boring code, and it's even needless code, right? You might be able to rely on some test library magic for this, to sort of implement, using reflection, value equality for your objects. I saw that at least there's been discussions in Shouldly if they should support this, right? But it's solving the wrong problem in a sense. What you're trying to do is compare JSON text. Right? You're trying to compare text, but with the knowledge that is actually valid JSON. And because I couldn't find any tool that does this in .NET, I had to write them myself. So there's a tool called Quibble, and it has also a sort of companion tool called Quibble.xunit that you can use from your XUnit tests to use Quibble. And the purpose of Quibble is to sort of have this JSON-aware string comparison. It's a very simple tool, but I'd like to show it to you. Let's see. That was my validation test. Don't need that. Okay, so actually, let's do this one. And I'm going to skip this one. I don't know. Okay, so I have, again, a JSON document. Let's see if I can find it. These are my content text. This is going to be my expected JSON result. Looks a bit similar to the example we had before. And I'm going to compare that to this. And at a quick glance, maybe you can sort of catch that there's something that's not entirely the same. But let's try to run Quibble. Yep. Can't type. Okay, that didn't work so well. There were some mismatches. Let's see what Quibble tells us here. Well, first of all, it lists both the expected and the actual JSON document that it got. But it also says specifically that it found two differences. First, it found a mismatch in the first book, and it says that it found this additional property addition. And it also says that there was a problem with a string in the author property here in the second book. It expected Leo Brody, but it was Chuck Moore. That's obviously wrong for this book, right? Thinking Forth, which is actually written by Leo Brody. Chuck Moore is, of course, the author of Forth, the language itself. Right? Easy to mix it up, but it's a mistake that you want to catch. Now, of course, just looking at these two JSON documents, you would probably be able to say, okay, I can do this by manual inspection. It's not that hard, right? But of course, real-life JSON documents rarely look like this. Real-life JSON documents tend to look something more like, let's see, like this, right? There's a lot of stuff there. And when I compare that to my expected thing, well, there's a lot of stuff there too. And it's not so obvious where the differences are, if there are any. So let's try that also. Okay, let's see. I should be removing, oh, this is the wrong thing again. So same kind of test, just compares. It's really exactly the same thing. It just uses a different JSON document. So trying to run that. Sorry? Oh. Haha. Oh, that's unfortunate. Thanks. Okay. Try to run it again. See what happens. Now, again, there was some mismatch, but because the documents themselves are so large, this is getting a lot more useful now. So it says that it has 4 differences, and exactly what they are is not that important, but it's sort of the important point that it points you exactly where in the JSON document there was a problem. So I think Quibble is useful. If you work with JSON in .NET, I hope you might too. Okay, so finally, let's go through the summary now. First, my plea is just please let JSON be simple. JSON is simple. Don't write complicated code to work with something that's simple. Avoid all this needless magic. And don't write a JSON parser unless you absolutely have to. And make sure, if you think you have to, make sure that you actually have to. JSON serializers should just serialize JSON. That's all they should do by default. JSON documents are going to need a contract, an explicit contract. We should stop discussing internal details when something goes wrong when we exchange JSON documents. We should write these contracts by hand because it makes for much better contracts and it also makes for much better collaboration practices. We should validate that our JSON documents are actually valid. And finally, we should use Quibble to compare JSON documents as JSON. Thank you. Oh, I forgot to say, are there any questions? One question.
So system text JSON was released, and a lot of people complained that it wasn't as convenient as Newtonsoft. Do you have any comment on that?
Okay, so the question was, a lot of people complain when system text JSON was released that it wasn't as convenient as Newtonsoft. And what can I say about that? I can say that that complaint obviously stems from the fact that we've gotten used to all these conveniences from Newtonsoft. My approach would be to sort of sidestep the problem altogether by letting Newtonsoft do as little as possible, and then let system text JSON do the exact same job, right? It shouldn't be sort of this mismatch, and the pain then of converting from Newtonsoft to system text JSON is caused by the fact that we used all these conveniences. Any other questions? There's a question up there. So you said, what do you feel about auto-generating JSON DTOs using some tool from a contract, something like that? Or So generating from the contract into DTOs. My position on that is that I probably wouldn't do it myself because I prefer actually writing it. But it's an implementation detail in a sense. As long as you have the contract, I don't really care how you author your code in that respect. So, but from my experience, often, well, first of all, there are things that are hard to generate, things that you can express in JSON schema, for instance, that don't really map over that well to the .NET type system. So there are things that are going to be lost on the way, and then there might be things that you want to re-add afterwards. And whenever you have this, it's going to generate something that's almost what I want, but not completely. Then you're sort of in a pain spot, right? So, yeah. Any other questions? Oh, well, further's out there. Right, so the question was, in XML, there's this XSLT transformation that allows you to transfer from one XML format or a document to another one. And you have something similar in JSON, is that the question? Or? Oh, to HTML. Right, right, so not necessarily to another XML document, but to something else, right? To whatever. Right. I'm not aware of any tool that has broad acceptance that does that for JSON. And should there be? I don't know. So I don't really have a comment beyond that. So perhaps if you want that capability, use XML instead of JSON. Using XML is just fine, right? So transforming from okay, so transforming from JSON to XML, and then you can use a style sheet. I would ideally then don't produce JSON in the first place, just produce XML if you can. But of course, if it's another system, I don't know, probably there are going to be some pain points with that, but I have no personal experience trying that approach, so. Yeah. Yes, another question?
Yeah, what when the JSON schema standard doesn't implement the restrictions you want to put on the XML, so you can't express your content there?
Okay, so the question was, what if JSON schema doesn't have support that allows you to express the constraint that you want on your contract? Is that? I don't know. I haven't been in that situation myself. I would say probably.
Like you need unique IDs for some tree or something.
Sorry?
Like when you need unique IDs for a tree or something, or when those fields should be matched.
Right. So maybe there are some sort of whatever value you have over here should also match some value over here, something like that. I think as long as you don't have sort of support in the tool that in the specification that you're using for your contract, you're going to have to resort to writing it down in the contract as free text. Right? You can add constraints like that just by typing it out in natural language. That's my best. I don't have anything beyond that. So how are we on time? Are we done, or 1 minute? Is there a short last question? Preferably one where I can say no. Okay, I think we're just going to leave it at that. Thank you.